My name is Ross Buchholz and I represent SIM out of Charlotte, North Carolina. And today I'm here in, where am I? Yorkville, Illinois. And I'm talking with Jason.
Jason Fowler with Schaefer and Rowland, or consulting engineers.
Jason, glad to meet you today.
How you doing? Licensed Illinois professional engineer and a licensed wastewater operator in the state of Illinois.
Fantastic.
So today we're here at Whitetail Ridge Golf Course, where we have the clubhouse that we treat the wastewater system. It's a 6,000 gallon a day system. The water basically is generated from the cooking, the laundry services, the locker room services, those sort of things on site. It flows by gravity over to our pump station over here, which is a package type pump station. Mm-hmm. It has 2 pumps in it. It runs on a float system similar to a residential ejector system. What it does is the water flows into there. When it hits a certain level, it pumps out of there. It's ground up, macerated, and flows into the bottom of our treatment cell over here, which treats 6,000 gallons a day over a 365-day year treatment season. And basically what we do is we store in the wintertime, we irrigate in the summer. So what you're looking at now is the highest the water level is going to get in the springtime before the irrigation season starts. And as the summer months go on, we irrigate in the area around here. This fenced-in area that you see around here is the permitted irrigation area. So we irrigate in the upland area around the treatment plant here. And so the water's irrigated throughout the growing season. By the time we get to fall, November 15th is usually our shutdown time. We drop this about 3 or 4 feet, and that's our working depth for treatment and whatnot during the winter season as the storage begins to fill back up, and we start the cycle right back over again next August. The treatment cell is 15 feet deep. It's got a 3-to-1 side slope. We inject the waste in at the bottom of the treatment cell. There's an anaerobic digestion that occurs at the bottom 1 foot below our patented Mars aerators that we install in the systems. The Mars aerator is a combination of fine bubble and large bubble. The center tube is a static tube that creates a Venturi effect. It pulls up that debris and the digestibles from the bottom and introduces them to the cloud of bubbles around the Mars unit itself that are generated by those fine bubble diffusing discs that are positioned around. There's 8 discs around them. Each Mars is driven by an individual compressor. So there's very little mechanical working parts outside of the pond. There are no mechanical working parts inside the pond. We simply just pump air into the bottom of the lagoon, into the Mars system through the individual air compressors. That treatment process occurs over roughly 40 days to complete the treatment process, as the water generally migrates from one side of the pond to the other, where we draw out through an irrigation pump and pressurize our irrigation system and irrigate the land around here with generally pop-up irrigation sprinklers. There are different types of irrigation that you can do, cropland irrigation with center pivot rigs, standpipe irrigation, even flooded irrigation where they open a sluice gate and the water flows out to a crop and floods the crop to treat it. So that's the process. We go from raw waste inside, produced from the use inside the building, ground up, treated, stored, and then irrigated on the irrigation area that's around the pond.
That's fantastic. Now we're talking to you today about the possibility of you putting the system in at our compound in Liberia, Africa. Mm-hmm. What would be the advantages of that system being used at ELWA in Liberia, Africa?
Very simple operation. There's not a lot of moving parts. There's not a lot of mechanical pieces. Really, we're just looking at air and time for the treatment process. So you're not dealing with mixers or digesters or anything like that. You're simply introducing air into the water over a period of time to treat the water in that process. It's very simple operation to do. Mm-hmm. You've got a readily available pumping station that comes as a package station. It's a fiberglass enclosure. It's shipped all over the world, complete and ready to go in a hole. Hook up the pipes and you're running in within 24 hours of getting the equipment there. The Mars units, again, are simple, dropped in, either in a wet or dry application. Mm-hmm. Unlike traditional static tube aeration that is connected in a lattice form along the whole bottom of the pond, these are dropped in wet condition. They can be pulled up and serviced without having to drain the lagoon. So it's very easily accessible, very easily maintained. It's a lagoon-based system, so you're working with the earth and the raw materials there to generate and create the lagoon itself. And then again, your irrigation pumping system can be as simple as a sluice gate that opens up and lets the water flow off the top of the basin into an irrigation area where you've got a growing crop, or it can be as sophisticated as a pump with an irrigation center pivot rig or some sort of stationary irrigation system.
So besides the ease of installation, what would you think would be some of the other benefits that our compound at ELWA might be able to see and realize?
Well, the treatment of the water, rather than just discharging a raw wastewater into a receiving stream, you're getting the benefit of not only treating that wastewater that you're generating and creating a reusable resource, meaning the irrigation water to go, and it has a second life to it, basically, is what you're giving it a second opportunity to grow a crop, or to grow trees, plants, things like that definitely will benefit the area. So it's ease of operation over time. This facility has been going for 10 years now, and there's been no maintenance on the physical structure itself. There's some mechanical work to be done. So in an application like that, we've looked at applications similar all over the world: China, Mexico, South America, and really what draws them to it is the ease of the operation of the facility. Once it's in place, it doesn't take very much skill to operate the facility, and the folks there can be taught in a rather short period of time on how to operate efficiently and effectively and have a long-lasting system in place.
So really, you don't need any operators licenses or anything like that.
You do in the state of Illinois.
Right.
I'm not sure what the responsibilities would be in Africa, but I could teach you how to operate this facility in 6 hours probably, and you'd get a good handle on it and how to run it. It's not a very sophisticated type system. It's very straightforward, and it does a great job of treating the water.
So this is your smallest system that we're seeing today.
Correct.
What's your largest system?
Our
that
largest
you've
system
installed?
is in China. In Beijing, China. We designed it around the Olympics in Beijing.
Wow.
That treats over 200 million gallons of water a day. Our local largest facility is in Mill Creek, which is in Geneva, Illinois, which is just north of here by about an hour. That's 650,000 gallons a day. So you're looking at the very smallest version up to the largest version up in Mill Creek, and then worldwide our treatment in China was the largest system ever designed. But it uses the same technology, the same basic principles: lagoon-based aeration, air, time, irrigation system, storage, all the components are the same. They're just scaled down, and that's another great benefit of the system, is it can be scaled to fit the particular use, and it also grows with the use as well. So as the system generates more waste or less waste, the system will work either way. So normally with a conventional treatment plant, you need a solid base flow to keep that bacteria working and the sludge being produced and reintroduced into the system. Here we can operate on 1 home or 500 homes. It doesn't matter what the loading is on the system. The system will function, and the same process will occur regardless of the loading on the system. So it can be built, it can grow with the community that it's in, it can also be added on to and grow larger. And a lot of the components are, all the components are used again, but additional components are added, and the system is just simply expanded with either another cell or an expansion of the existing cell. So they're very, they're very user-friendly in that respect too.
Okay, that was a big question: is how, as our flow, as our output increases, how do we grow with the system?
Right.
And you just answered that question.
Correct. Yeah, we would likely design it for some target horizon, but we don't need to have that flow on day one, whereas with a conventional treatment plant you'd have to have that kind of flow, or generally a good portion of that flow, on day one. So we can come into an area that has a small community with plans to grow, and we could simply grow, they can grow into the system that we build and design for them.
Jason, we're talking about applying your system to our compound at ELWA in Liberia, Africa. In terms of all the other benefits that you've just described to us, obviously in that area there's a lot of agriculture, a lot of farming. Could the effluent that comes off of the water, the effluent that comes away,
Yes.
does that have any nutritional value for farmers in terms of growing crops and plants and things like that?
Yeah, it absolutely does. Unlike a conventional treatment plant where they try to strip the nitrogen and the phosphorus out before they discharge it into the rivers and streams, so it doesn't grow algae and doesn't pollute the rivers from that respect. We don't do that type of a treatment here. Basically what we're breaking down the waste, but we leave those nutrients intact. So the nitrogen, the phosphorus, the same things that are in the bagged fertilizer that you pick up at the store are still left in the water and can be applied to the land, and definitely will benefit a growing crop for sure.
Jason, one question. At ELWA in Africa, in Liberia, Africa, what would be the next steps for us getting this installed and starting the implementation process?
Well, how we start basically is with an engineering report, or we look at what the basis of design is for the system that we're looking at. So we want to know what is the target connected units, homes, whether it be residential homes, commercial, hospitals, schools, all those things. We just want to know what the flow is coming in. From that, basically, we take that information and run with it. We design a treatment cell, storage lagoon combination like you see here, simple one-cell system. We determine the amount of air that's needed, the cubic feet of air per day that goes into that. So the design process really can take off as soon as we know what our target treatment area is, and the flow coming into the plant is really what drives everything.
Okay, so so when we go to install this, would our personnel install this, or would you help us install this, or how would that work?
Your personnel would easily be able to install this,
okay.
And it's a simple, a lot of the stuff is just shipped worldwide. It's simple installation instructions. Like I mentioned, the Mars, just drop in a dry or wet application. Earthwork activity is being done likely in that area now as it is, and it can simply be done. The treatment cell is dug 15 feet deep at a simple 3-to-1 slope, which is done with most readily available earth moving equipment. It can be done very easily. It can either be synthetic lined or lined with native material like clay. We want to make sure that there's no, the water is held in the pond, but it certainly can be done by the local folks there.
Okay, so your system would work with any and all soil conditions then?
You need to have, if you're gonna use native soils, to seal the edges of the pond, and there needs to be that, you need to be watertight. It needs to be a good clay with low permeability in it. Otherwise, there's synthetic liners that can be purchased and put in place that would act as that retardant to not allow the water to leave.
Sounds like a fantastic application, a fantastic product. Thank you for your time today.
Absolutely.
Thank
you
so much.
Appreciate it.